I think we should just get started. You know, if anyone else comes on, they'll just catch up with us. All right. Well, it's exciting that we're doing this. This has been a series of virtual Zoom socials hosted by the IWCA. We're excited. My name is Nathan Pierce. I'm on the board of directors with the IWCA and also chair of the Safety and Education Committee. Um, we have decided. My sound okay?
You're good now.
Okay. A topic that's really important in our industry is water-fed pole safety. There have been a few, recent accidents, fatalities, and I think with that in mind, we thought it really important to focus our attention on water-fed pole safety. And we have two people joining us on this call that I'm hard pressed to believe there's anyone more qualified to speak on this topic. So first, I wanted to introduce our sponsor, which is Tucker. Sean Gavin. Sean has been in the window cleaning industry for 20 years. He's owned and operated his own window cleaning company in Colorado for the first 10 of those years. During that time, he started Reach Higher Ground in 2006, for which he's still the president. RHG began with the idea of creating innovative water-fed pole systems and has continued to expand their product offerings. In 2015, RHG acquired Tucker, the oldest and most trusted brand of water-fed poles and brushes in the world. And with these brands, Sean and his team have looked for ways to innovate in the industry in order to make window cleaners more efficient and safe. I feel like a lot of old-time window cleaners will often say that they're going to grab their Tucker pole because that's synonymous with a water-fed pole. But Sean, it's great to have you on. Appreciate you sponsoring.
Yeah, thanks for having me. Thanks for all the hard work the IWCA continues to do in the name of safety. It's obviously very recognized in terms of the effort that's put forth to keep window cleaners safe. Now with lots of solar installations going up, we also have the introduction here of the solar panel cleaners and the obvious crossover between the two fields. Safety is an important issue for us here at Tucker, and we try and take it very seriously. It's concerning to us to see a number of accidents in the field, and we're trying to stay as on top of what might be going on in the field and what might be causing these things as possible. So just trying to remain in the forefront as a manufacturer and continuing to talk safety. You'll have a number of people that will shoot that idea down anytime it comes up. The old cowboys that want to pretend like nothing can ever happen to them. So it's important to us to be able to continue to focus on what is working and what's not working, and stay involved with folks like yourself to be involved in change should that need to take place. So thank you for the opportunity to be here.
Awesome. Thanks a lot, Sean. The person that's going to be leading kind of our discussion on safety today is Mike Draper. A lot of you know Mike has been in the industry for a long time. He first started cleaning windows in 1990, which he had to correct me on that because I didn't give him the adequate credit he deserves on the amount of time he's been cleaning. Right, Mike?
That is correct. My beard is grayer than what you were giving me credit for. So
first started cleaning windows in 1990, and after owning and then selling his window cleaning business in Illinois, Mike went on to work with Jay Racenstein, where he was their VP of Sales and Marketing. During that time, he worked with many window cleaning companies and saw the need for greater safety oversight in our industry. He took his product and process knowledge to launch Expert Safety Services in 2018 with the goal of providing safety products and consulting through hands-on training and their Safety Advocate program. Mike's also a certified instructor of the IWCA as well as an advisor to our board of directors. So thank you, Mike, for agreeing to speak on this topic. I know Mike and Sean have also worked collaboratively together in exploring and ways to make window cleaner safety safer with water-fed poles in our hands. So thanks, Mike. I appreciate you being on for this.
Hey, thank you. Thank you for doing it. I think it's a very important topic, and obviously with the injuries and the even more than injuries, the deaths that are occurring in our industry from this type of activity just necessitates more need and more exposure. So appreciate the opportunity.
For sure. So I'm gonna be passing this on over to Mike now. How this is gonna go is Mike's gonna be doing some content presentation about safety as it pertains to water-fed poles. So he's gonna be going through. He has some slides he's gonna show us. So it's gonna be heavy on the content, and then towards the end there will be time for some Q&A. So if anything comes up that you're kind of have a question about, I think it would be easier to be able to ask that towards the end, and Mike can kind of make his way through his presentation here. So I'm going to leave you to it, Mike, to go ahead and speak on the topic.
Well, thanks again, Nathan. Appreciate the intro, and appreciate everybody that's on and taking notice of this, and it's going to be recorded. So those that will take it in later, that will be awesome as well. So welcome to you if you're taking it in recorded form. But it is, as we mentioned, an important topic, and one that for the last several years actually has had a death associated with it, if not 2 or 3, with water-fed usage, and primarily. Obviously, that comes in the form of electrocution, and we're going to spend some time on electrocution today. And as was mentioned by Sean with Tucker, solar plays a new role in that as well, with a new electrical hazard there. And so we really, the goal of this is really to make awareness of the safety precautions that are needed on a water-fed site, and then also really try to get out in front of the fact on solar. Because we haven't had an incident yet, but we don't want one. We don't want to have what's occurring window cleaning wise with solar. So if we can get that education out there earlier, the better. So again, thanks for everybody for being on, and I'm going to share my screen, and hopefully everything's gonna work right here. And you should be looking at my presentation screen. If I just get a thumbs up from Phil or somebody telling me you're good.
Yeah, you're good.
All right. Okay, great. So when we think of water-fed safety and contact with power lines, and that's really something that, it's something that we need to talk about. And the one thing that we want everybody to take away from with this presentation is there's no substitute, there's no PPE out there. There's no got an insulated base. There's none of that is going to be a good substitute for a good site safety plan. We have to take advantage of the fact of going and looking at the site to see what are the hazards there, and then try to either eliminate or mitigate those hazards the best we can. But so often I think what's happening is there's a mindset that, we're already being safer. We're using a water fed, so we're not getting up on a ladder. We're not getting in the air. And so while that is true, that we have maybe negated the fall hazard risk, there are other risks and other hazards out there that aren't taken into consideration or not taken seriously. So what are they? Electrical hazards, those are the ones we're going to spend the most time on, but really surrounding the whole water-fed site safety, traffic hazards also come into play. Fall hazards with the pole and other things we'll talk about, ergonomics of that. Just the building management sometimes we're using water-fed pole where other access isn't there. And so we need to manage our buildings and know what the obstacles are. And then auto crash. And the reason that we bring this up is because so many guys now they get into tank systems. And even if they're not in a tank system, even if they're in a mobile cart or what have you, the mentality out there can be, just throw the thing in the back of the truck and we're going to go down the road. And here with a Tucker system, a fill and go system, whatever, you're carrying 50 gallons of water. So that unsecured is a missile. And so that plays into the fact too, also with water-fed safety. But let's first start talking about the electrical hazards. And we're not going to spend a tremendous amount of time in the solar category today, because it's really its own set of training. And the IWCA will soon be releasing an actual solar panel safety training course here soon. And so we really encourage you to take that. But we do want to talk about it just for a minute. And the reason is because with more and more of these fields going up, we have to understand that sometimes we have the mentality that DC power can't shock us. There's not an electrical risk there, but that's wrong. It can shock you. And if you talk to installers or even some cleaners, they will tell you stories of being electrocuted while either maintaining or cleaning these. And so, again, we have a highly conductive material. We're putting water in play. And while DI water may be a less conductive material, it doesn't matter, because the carbon fiber pole that we're using is conductive. And so you'll hear too an argument that says, well, these things they're grounded. If they're installed correctly, you don't have to worry about this. That may be the case, but as a contractor, you don't have the installation history on these. You don't know what's going on. You don't know what's been maintained. And so you really have to go into a site like you're looking at with the mindset that I could be shocked here if there was a faulty wiring, a poor installation, anything like that. Wildlife comes into play. They like to chew on the wires. And now you have a unit that is potentially electrified, and you run your carbon fiber pole over it, and now you become the circuit between it and the ground. And so we just have to really think about this, and solar being a new place where this can occur. So again, we encourage you to, we're going to have some more. We already have the solar panel safe practices document, but there will be some more training on this coming very soon. And so we encourage you, if you're doing solar, to get some further education. But some of this will apply to solar as well. We have an inherent electrical hazard right off the bat. A lot of these pump systems, they have a pump on them. So you're introducing, or if you're adding an auxiliary one, they're electric. And so we plug them in, and we're running water. We're creating water. And so, just as you've been taught as a little kid, water and electricity don't mix, yet we're using it every day. And so one of the electrical hazards that exists, and it's really one that we can take charge of, is where we're plugging this in on a job site. And so we might have in our mindset, well, no problem. Even at a residential, you may say, you know what, the customer on the back deck, they have a GFI switch back there. But as contractors, we don't want to rely on that, because a GFI switch, if you don't know much about them, they are set to trip, but they have a lifespan. They're only set to trip so many times. And so again, because you're going into an environment you don't know about, you don't control, we really want to control that GFI ourselves. So not relying on the homeowner or the building owner's GFI, but really relying on our deal. And it's easy to do, right? Nowadays, you get a pigtail like this, you carry it with you, you control your GFI, so that if there's a problem between you and the electrical circuit that you're running, that it's going to be interrupted, and you can feel confident in that, not relying on somebody else's things. When we talk about electrical hazards, you can see this picture that's here, and we use this one a lot. And one of the questions we always ask in a class is, how do you safely clean this window? And most people may say, well, you do it from the inside, or you would maybe you would skip it, not do it at all. And that's probably the best answer. But really what we're looking for is, if we're determining that, look, I've got windows, I've got glass in an area where we see power lines, we don't want to guess. And sometimes you'll ask the question, well, how far away to that do I need to stay? I don't know, 10 feet, 15 feet, 20 feet, just use common sense. Well, that's we want to take safety a little bit more, take it a little more serious than just kind of guessing. And 10 foot comes up a lot, because that's the minimum in a couple standards that you'll see, but sometimes it may require a greater distance than that. And so here's the thing, when we're talking about minimum approach distances, how far we have to keep ourselves or conductive materials away from electrical lines, the minimum approach distance is determined by the voltage coming into the building. All right, that's the answer. It's not 10 or 15 or whatever. It's determined by the voltage coming into the building. And so it may be 10, and that's maybe a good starting point, but it may be greater than that. So again, we don't want to guess. And we really don't have to. I'm going to show you a couple slides here that we're going to be able to determine pretty well what the minimum approach distance should be based on what we're told and what the voltage is coming into the line. I know a question in your mind is probably like, how do I know? How do I know what's coming in? We're going to show you. We're going to show you a way that you could use as a guideline. So voltage coming into the building is a big deal to us, and it really should be in our JHA, right? We should have already done a site plan. We should have this in our JHA, and we should know. We should be telling our employees how far away they need to stay from it. Another thing that comes up with electric houses is the drop zone. Many times you may be working in a safe area, but the extended length of the pole, if it fell over, would put you in an unsafe area. We're going to show you a little methodology around that as well to use and utilize. And then we'll talk about conductivity. And hopefully no one out there is still thinking that carbon fiber won't conduct electricity, because it does, it will, it has, and it's killed people. So let's think about our minimum approach distance. This is a little slide that came out of an aerial lift training. And also you can find this in the OSHA documentation as well. They mention it here. But you can see now, we see where 10 foot comes from now, because in this document, or this little thing that's being used, you see 10 foot, but that's 0 to 50 kilovolts. All right. And so as those kilovolts go up on the left-hand side, you're going to see that also the minimum approach distance goes up as well. Now, I'm not going to say never, but we're probably, most of us in a commercial building setting and things like that, we're probably not going to get up over 200 kilovolts. But it's possible. I mean, you may be working in that, but it's just important to note that 10 foot, just saying up 10 feet, that's not always good enough. And so how will we know, though, what the voltage is? So we know how we can set up the foot or the minimum approach distance, but how do we know what the voltage is? Well, here's a really nice slide to think about. This is pretty universal all over the United States. And this shows the power lines and the power poles rather, and then also the kilovolts that those carry. And it's interesting. We just did a training for DTE Energy up in Detroit, and they concur. Yep, that is true. That's right. That, you know, those poles are universal, and it's a good indicator of what that's being carried in that line. So you can see if you're looking at the pole, and maybe it's a good thing you just have on your phone, feel free to take a picture of this or whatever. You can find it probably out on the internet, but just know, hey, here's the type of pole that I'm dealing with. And so here is my kilovolts. And if I back it up and have this slide as well, I know what my minimum approach distance is going to be staying away from those lines. So again, this doesn't have to be guesswork. We can have a pretty good idea right here. We're just using these two things, at least setting up what the minimum should be of staying away from these lines. Now, here's a problem that is in our industry, and this is what comes up. So I want you to look at this picture, and this is not too far off of a death that occurred in Texas. But I want you to look at that bump out on that building, and I want you just to ask yourself, how is your employee going to move around that bump out to get to the other side where there's also glass that he'll be using the water fed? And we know good and well that the employee is not going to lower that pole and put it down into a closed formation and then re-raise it on the other side. He's going to pull that out away from the building like this, isn't he? And he's going to walk with it. So this is a really good picture that shows right here, he may be maintaining the appropriate minimum approach distance, but what's behind him? There's high lines, right? And so when he tries to maneuver that, when he pulls that off of the building, he's going to bring that in closer contact then with the lines. And ultimately, we have to know too that we don't have to touch it. The case that was in Texas where that killed the individual, he didn't touch it with the lines. It arced off of the lines over to the pole in a very similar situation to this picture. And so again, we have to really think about the drop zone of the pole. Now, here's a nice little rule of thumb. We've got it in the slide there, but it's the pole, extended length of the pole is what we're talking about there. So let's just use, for easy math, let's use 30 feet. So we have the pole extended out 30 feet. So we're out 30, and now we're going to add a third of the pole. And the reason we're going to do so is that's going to take care of the angle that is created away from the base of the building out to the work area. Because most of your manufacturers have a little measurement that they use there. They're trying to figure out this angle to determine length of the pole. And so if you add a third there, you're going to be in pretty good case. So in this case, we're at 40 feet, right? 30-foot total extended plus a third, that's 10 feet. So we're at 40 feet, and then now we're going to add the 10-foot minimum. Now, you could add more than that if you knew the kilowatts was greater, you could add greater, but at least the 10-foot minimum. So in this case, this gentleman working here, if that is 30 foot of pole, he needs 50 feet of drop zone area in a 360-degree range. All right, does that make sense? So you take this total extended length, which is 30, plus a third, which would be 10, plus 10 as your minimum approach distance, and he needs 50 foot of circumference all the way around him. If he doesn't have that, you have that employee in a hazard. Because maybe it's a windy day, maybe he pulls it off and the wind blows and it blows it into the lines. Now he's subjected to that hazard as well. Maybe it arcs, maybe we're dealing with a higher voltage than we thought. So, but by really thinking that through, and if you don't have it, what should be done? Well, we would love for you just to eliminate the hazard. We'd love to say, don't do it. But we're also realists. We know that, that somebody wants to pay you to do that glass. But could you set up something? Could you set up possibly maybe a safety monitor or something in this case where we don't maneuver the way that we just described, which we know the employee will. They'll pull it right off the glass and try to walk around. Maybe we create something that's going to remind them that we have to lower the pole during that bump out. And that would be mentioned in your JHA, right? You'd be conveying that to your employees. Hey, you've got a bump out on that one side of the building. Electrical lines are there. Please don't walk around with the pole extended. Lower it down, extend it back up. But all these things have to be thought about. And again, pole plus a third of the length plus 10 feet gives you a nice, again, just a nice general way to think about drop zone on the poles. Conductivity, we talked about it a little bit already, but just know carbon fiber absolutely conducts electricity. This is a pole that unfortunately resulted in a death as well. You can see this is a base section of a pole, and it blew out there at the base right near the head, and it conducts electricity. So we need to get that in our heads for sure, that we are walking around with something that is conductive. This on the right-hand side is also a death that occurred with a water-fed pole. That is a water-fed pole in that bag, by the way. It's a 65-foot pole. It hit a high line in Huntington Beach, California. That's what's left. And unfortunately, the guy died as well. So we can see that electrical does play a problem. It's a hazard out there, and we have to take it serious. I'll go this much further. It's not that we just have to take it serious. We got to take it a lot serious than we've been taking. Because 2 to 3 people is kind of our statistic right now a year is what we're losing. That's just been in the United States. Now the IWCA has been involved with ones in the UK and Canada, and it's happening more and more frequent. And so we have to take it more serious than we have. Don't leave these things to chance. Go out and look at these job sites. You employers out there, there are OSHA rules that govern this already. We don't have to make up water-fed rules. They're already on the books. And one of them here is just on the left-hand side. It just notice how OSHA 1910 mentions this. It says employees working in areas where there are potential electrical hazards shall be provided with and shall use electrical protective equipment that is appropriate for the specific parts of the body to be protected and for work to be performed. So right there, we're talking really about PPE. And you might not have thought about this before. You might have thought, wait a minute, PPE for a water-fed pole? What would that be? Well, we'll talk about it here in just a second, but I want to the right as well, it says that when working near these exposed energy conductors, which we are if we're around lines, that the employee shall use insulated tools or handling equipment. So again, when you as an employer are making purchasing decisions, if you're going to be having guys around electrical hazards, and I know sometimes it is because you've got, we've heard where guys are working around the metro, or they may be working in downtown areas where there is absolutely electrical hazards, then we have to be thinking about the types of tools that we are handling. Are we taking the extra precautions? I will say this, none of the manufacturers at this point in time have a pole that would meet the criteria of the OSHA requirement here. Now, several of the manufacturers have taken steps towards it, right, with maybe insulated base sections and things like this, but no one will meet the criteria of the UL rating that would it take to get under an insulated tool. So just know that. But at least as an informed buyer, you could say, hey, what are you doing to that base section or other sections as well? So let's talk about those protective base sections. One of the things that it may do is it may cause a false sense of security. Because when you have these base sections, Ionic makes one, Gardner makes one, Tucker makes one, and there may be others coming, but the base section is the only section that's insulated. And oftentimes when the pole is extended out, the reason that a person gets electrocuted is because the pole goes over in some way. Well, when it goes over, what's the human tendency? The human tendency is to want to catch it. You'll generally reach up higher, and you may grab the second section of the pole that's not insulated, and guess what you just became? A circuit to the ground. If you'd have kept your hands on the base, you'd have been fine, but human instinct is I'm going to try to save it, right? And so we might say, well, that second section needs to be insulated too then, Tucker. That's what we need you to do. Make sure that second section is. Well, that wouldn't necessarily solve it either, because we don't know which section a person's going to extend. Most of the time, you're going to extend the lightest section. So you might extend the top section out and use the base. So even if they insulated the second section, it wouldn't matter because you got the other section out. So we just want to make sure that we educate and know, hey, it's great that you're using an insulated base section, but know that it's not the end all. And it's not, the illustration I use all the time for this is just because an electrician has a pair of rubber coated pliers, he never has the mentality, I think I'll go grab 220 with these. No, it's for an accidental bump, right? It's an accidental incident that he hopes that will prevent him from getting into. And so we have to view these base sections the same way. Don't view them as a license to be stupid. Oh, I've got an insulated base section so I can go out and work around high lines. No, that's not what anybody wants you to do. That's not what Tucker wants. It's not what Ionic wants, Gardner, anybody wants. Also, we talked about PPE, and we stress this and talk about this a lot with solar. And really, it needs to be talked about quite a bit with just water-fed in general. And here's a couple pieces of PPE that could be utilized that I personally feel like if they were, several of the deaths that we have encountered would not have happened. And so the first is what they call dielectric boots. And this is just one sample. We're not promoting any brand or anything like that. We're just showing you examples. And these are a shoe that basically has a insulating factor, and they in essence they won't allow your body to become the ground. All right, and so if you're wearing them and you was to have an arc or something like that, the only way that it has to have a complete ground, right, in order for electricity to travel. It's the reason a squirrel doesn't get shocked or whatever when it's walking on a line. So it's the same thing as we're going to wear these, and that way it's going to help prevent a grounding, if you will. The other thing is these gloves. They're rated gloves, and they are also going to. So think about this: if the guy where the pole went over, and we've had this. Actually, this is one of the. We're not just talking about this in theory. This has happened. So the pole goes over. He actually had an insulated section. He grabs the second section and he's standing there getting jolted because he, again, completes that circuit, right? if you would have had the insulated gloves on, might we be thinking about it differently? And so again, having the gloves and the dielectric boots would have been even that much more of a protection. And now think if we're using an insulated base section and we're using dielectric boots and we're using insulated gloves. Wow, what a better situation that is. And we're maybe trying to set up minimum approach distances and drop distances. Then we're obviously, now we're really starting to mitigate that hazard the way we should be. So the PPE can be worn and should be worn when, especially if we've determined in a JHA that electrical lines exist on the job site, regardless if you think they're going to stay away from them. Don't take that. If they're on the job site, then we need to protect our employees. All right. No one in any safety incident, we don't get to interview the dead. But no one leaves that morning thinking, you know what, today's my day. I'm going to get shocked today. Everybody leaves that morning thinking that I'm going right back home to my family or whatever as soon as I get done with the day. Unfortunately, some haven't. And so by taking these precautions, we help ensure that somebody is going to go home at the end of the day. Fall hazards. We talked a little bit about this. Electrocution is obviously the biggest risk, and it's the biggest thing out there. But these fall hazards, because electrical lines are oftentimes away, we have to think about the fall direction of the pole. Where could it go? And if you look at these guys cleaning, we have to think the guy that has it extended in the air, look at that situation. Where could that pole end up? Well, it could end up all the way down the side of the building if the wind blew it or he lost control of it. It could land on the guy possibly that's working there with him. It could land on the car. It could land on a pedestrian coming. And so we really have to think about these things. And I think it's been kind of short-sighted on our industry just because we've kind of built a false sense like, well, hey, I don't want to suspend off that building, and we're not going to get ladders out. We're going to use the water-fed pole, and we're safe. We don't have to think any further than that because we're using a water-fed pole. Wrong-o, right? There's more considerations that have to be thought about. So really giving consideration to our fall direction, and specifically with electricity, we'll emphasize it again, extended pole length plus a third plus 10 feet. In order to have a safe minimum approach distance surrounding you. Traffic hazards also obviously exist. If I go back here, these guys are maybe working on a day where there is no traffic in that parking lot. But what if it wasn't? What if it was Monday morning? How are we protecting our workers from the traffic that's there? It could be pedestrian. As we're mentioning here, we are spewing water all over the place. So we may be creating a slip, trip, and fall hazard just by what we're doing. Certainly in the solar industry, we're on a rubber membrane roof. We're up on a commercial building and we're just shooting water all over the place. And we are creating a slippery mess up there. And so we have to give some thought to that. Traffic hazards as well. So pedestrian and actual vehicular traffic is what we always include when we're talking about traffic hazards. And using cones, keeping traffic out of our work areas. Unfortunately, we witnessed one time, it was after I had sold my company, but they had a very serious injury where they were using a water-fed pole. They had coned off an area well out. It's 150 feet away from the job site. A car just blew through all the cones and hit the guy dead straight on. Now, they did not do their diligence. They had set up safety parameters and things like that. But guys, I stress it all the time in all kinds of our trainings. Human intelligence is on the decline, and so we have to do everything we can to really think about and keep our workers protected while they're out on the job site. So in this particular case here, this picture that you're looking at, just think about that. Susie Johnson, she's late to work that morning. Oops, she sees that place is open. You think she's thinking about that worker? No. She's going to whip right in there, right? And so if we have workers in that area, what have we done to try to protect them? Have we tried to set up cones? Have we tried to set up barricades where we would keep our workers protected? Because again, they don't care about us. They're not looking for us, and their intelligence level is on a decline. Ergonomics, it's what we might call, sometimes it's referred to as like a fluff safety, but I will say if you've run a water-fed pole for a period of time out there, it's real, right? Your neck strain and all of that is there. And if you happen to take, carts or whatever off the truck, they can get heavy loaded with water. And so we just want to talk about just, knowing and talking with our employees about, hey, take some frequent breaks, trade off. Sending one guy out for an 8-hour water-fed job may not be the best plan. His chiropractor will thank you, but he might not. So, really keeping our employees in mind there. And there's ways to deal with these ergonomic issues, but it's just something we need to think about before we're sending guys out. Building management. So this is something that we need to think about, because again, our mentality is, well, I'm going to use a water-fed, so I'm safe. Well, on this particular building, we see water-fed in use, right? But do you notice the extra hazards that are potentially there? So over on the far right-hand side, the picture doesn't show you very well, but that's a drop-off. That drops off to another roof level. And so we have a fall hazard there. So you thought you took the fall hazard out of the scenario by using a water-fed pole. Well, you did on one regard, but you're still walking around. You have a walking working surface rule in place that if you could fall a greater distance than 4 feet, you've got to be tied off. So you've got that hazard. Look behind them directly. There's a skylight. And a skylight in the pressure washing industry 2 years ago, there was a gentleman killed for walking. He was walking backwards on the roof, spraying down bleach and surfactant, stepped up on the skylight. It broke, and he went down through, and he was killed. And so these skylights, wherever they're out on a roof, they're a hazard. They are a drop hazard. So we have to think about them. We have to plan our work so that our employees understand, hey, there's a fall hazard over on the right-hand side of that. So when you're working up there, we don't want you to go within, 6 feet of that, whatever the case may be, but setting up the plan. And then just extra people up on these roofs, they're a hazard. So now he may be a worker, but as he starts to walk around, it's something we might not think about, but we're creating, look at this roof. You can see the water on the bottom. So now you've got another guy walking around up there. He's going to trade off with you, but he is under a slip and trip hazard. And then also if he starts walking around or starts doing other things, he's in the potential line of a drop hazard if the pole was to come over or anything like that. So again, we're not saying it's bad. We're just saying you have to think about it. You have to manage this. You mitigate this risk when you're out on the building to help alleviate some of these accidents. So we'll finally talk, before we get into Q&A, we'll talk about just systems in general. And we see this a lot. You'll see, hey, post your rig up on the internet right now, and you probably see a truck, and sometimes it's heaping full of stuff, right? And but I just want you to think about, if you're in an accident, what's going to happen to that heap of stuff? Well, it may come up to the back windshield, it may affect you, and it may affect others, right? And specifically with water-fed, we just want to spend just a minute talking about, because it seems like they're getting more and more popular, is these tank-mounted systems. And if you've got a tank-mounted system, we know that a gallon of water roughly weighs around 8 pounds, right? So if you've got 50 gallons of water that you're carrying in a fill and go, and you get into an accident like this, and that tank system is not bolted down, the amount of weight and the force there is tremendous. All right, it's going to cause some problems. And so again, just using sense here, but anytime we've got these, and even if it's just an RODI system tall, 3 filters or whatever, if that thing gets launched out of a truck or launched into the back of the truck, it's a missile as well. So we need to tie that stuff down, specifically tank systems. They probably need to be bolted down so that they can't come undone in a crash. So this will be the end of our presentation. We hope that we highlighted some of the hazards that are really associated with water-fed safety. And we would like to now just open it up to, I'm not calling this necessarily an extensive training, but it's just a high-level overview of some of the hazards that you may face. And we'd like to open it up to the audience to any questions that may have. And I'm going to stop sharing just so we can have a little better interface here. So, and I can see hands, I think. Yep, I can. Are there any questions of information that we covered today? Things that maybe even you want to comment and say things you didn't realize, and maybe take back a different perspective.
Yeah, I'll start off, and people can think if they have a question they'd like to ask as well. But first of all, I really appreciate the content there, Mike. It's really good stuff, and just super valuable and important. I know some people might be aware there was a cleaner in the UK, Jason Knight, that was killed. Or actually, sorry, he was very badly injured. He was not killed, but he almost was killed. Just barely missed his heart, how badly he was electrocuted. But his father's been putting out a lot of information about just the hazards of that you can experience when using a water-fed pole, and things that he just didn't know about, that he just wants everyone to know about that is doing this type of work. So a lot of what you said, Mike, is some of the things that Jason Knight's father has been trying to get out there. So if you want to learn more about his story, IWCA has put out information about it. You can look up his story online, Jason Knight. But my question has to do with just the insulated base about water-fed pole. I guess if Sean was still on the call, maybe he could have helped field this question. But what is it exactly that is insulating the base of the pole, and how do you know that you're getting a pole that is insulated? How obvious do the vendors make it that you're getting a pole that has an insulated base? I guess it's like a two-parted question, I guess.
Yeah, no, I think I can answer this question. So the material itself is what is causing the insulating factor, right? So they're going to use a high fiberglass blend in that. And if you've been around the industry at all, I mean, Sean kind of alluded to it. Tucker pole was an aluminum pole, right? And if any of you ever run those, you got bigger arms for it because they were heavy. And so the tendency of the industry then was they kind of went from the Tucker pole, they went into fiberglass poles. And fiberglass was great. It was lighter than the aluminum, but it was very flimsy, and they were more heavy than what the next thing was, and that was to go into a hybrid pole of kind of a carbon fiber and fiberglass blend, and then they ultimately went into glass or carbon fiber, and then high mod carbon fiber. So the problem is that the industry took us along this journey of progression into carbon fiber for the most rigid and lightest material, but it's also the highest conductive. So the manufacturers, they're like, well, every time I add a carbon or a fiberglass section to create insulating factor, I'm also losing the advantage that the marketplace has dictated. If that makes sense, right? You're losing rigidity, you're losing lightness. And so most of the manufacturers right now, they're stating, I mean, Tucker, I know that they had a third-party test where they basically put electrodes on the pole and they ran it through, and at the base section they can't get a rating on it. Ionic, Gardner, they've also done up to 1,000 volt, and it's actually right on the base. It says that. So great. It's a good start. I don't want to knock any manufacturer for going down that road, but I really hope that some of them will respond and really go to the next level, because we don't need any more rules. OSHA already says you have to do it. So as an employer, if I'm going to put my guys in that way, and for solar, I am every single time I send a guy out. So we're hoping that maybe somebody will release and put a UL on it. Maybe it goes back to a carbon or a fiberglass pole rather. I know if I was doing solar, because I'm not really interested in the rigidity vertically, I'd have guys in fiberglass poles every time. But most of them are identifying it. And hopefully somebody will step up and say, hey, I'm going to go the insulated route so I can have that insulated rating.
Mm-hmm. Nice.
They're also scared. I'll tell you, the manufacturers are scared to death of this. Because they know how people are. So they're scared to say this is an electrical rated pole, because then they know that people are going to have in their mind, well, we'll just go out and be dumb with this then. And, we may have further accidents. So
Yeah.
there's a liability that they carry. But right now, by not saying anything about it, they're just like, it can conduct electricity. You shouldn't have done it. They lessen their liability than to go down this road.
Mm-hmm. Mm-hmm.
Unfortunately.
Yeah, that's good background information about how it's developed in this way, is that how they are now. Carbon fiber is it's more efficient, it's stronger, but it's also more conductive.
Yes.
Yeah.
And Gabe has his hand up.
Go ahead, Gabe.
Yeah, so I'm aware of 3 incidents so far this year. That one in the UK, one in I think it was Kansas City, and then one in Canada. I think the one in Canada, the gentleman passed away. He was electrocuted. It seems pretty high for me, and I don't know if maybe there's some others that I'm just not aware of. But I can't remember a time where we've already had 3 incidents so early in the year. In the first half of the year. Is that the case, or is that what is the average type of injuries with water-fed poles that has happened? And if it is higher this year than normal, what do you think might be some of the reasons for that?
Well, yeah, I don't know by month. Certainly, we're earlier in the year. I know that statistically, over the last 2 or 3 years, and I'm sure there's others out there we don't get, or sometimes we don't hear about them. But it's been 3 to 4 a year, unfortunately. So yeah, already having 3, and it's only June. It's not a good sign. I don't know. I think it's complacency. In the ones that I've directly been involved with, it's just things change. They didn't think it through. They didn't. They honestly just workers kind of think that nothing's going to happen that day, and unfortunately, that's not the case.
And I mean, do you think it's also going along with the trend that it's just becoming more and more common to use water-fed poles? I mean, it's now a lot more vendors are selling it. I know it seemed like it's been a lot more popular in the UK for longer to use water-fed poles, but certainly seems like in the US it's becoming such like a go-to for doing it. And not even just commercial jobs, but residential and all types of window cleaning scenarios.
Yeah, no doubt plays into it. I mean, it's there's more of them out there. There's no doubt about it. And then also, there's more people using them in different ways. Like one in our industry, they weren't even window cleaning; they were hanging Christmas lights with it, right?
Huh.
And so you've got not only are there more of them out there, but they're out there being used in different, more capacity than maybe it has been in the past. So which increases exposure as well.
Mm-hmm.
Mike, I have a question.
I have a question. Oh yeah, Brandy.
Yeah, I know we talked about this on the Safety and Education Committee, and I'm just curious if you can speak on it, and the other people who weren't in that committee who are on this call can maybe give some feedback. I'm curious if the IWCA needs to do some more work to bust a myth that's in the industry, which is pure water is non-conductive. Can you speak on that?
Yeah, absolutely. So, we we get into conductive, non-conductive, whatever. Will it not? And the reality is yes. I mean, if you were in a science lab and you had all these control factors, and you said, okay, if I took well water that was highly condensed with whatever materials, let's just say rust, all right, and you put that up against, you ran electrodes through it, and you got a reading, and then you got a reading over here on pure DI water, you're going to come up with the fact that DI water, because the impurities and the metals and all that stuff are taken out of it during the filtration process, that it's going to be less conductive. All right, it's not non-conductive, it's just it would be less conductive. But I guess my point with the whole thing is that who cares, right? It's like saying it's like saying, you know, to the electrician, well, the metal piece will electrocute you, but the rubber, it's less conductive. Who cares if you're working in an environment and you have a hazard, then and you do, because in my illustration here with the electrician, you have metal and rubber basically, right? DI water and carbon fiber. So it doesn't matter, you're carrying something that basically is conductive. So the water need not even, it is interesting. I studied Sean's testing really closely, and it was interesting that they were trying to see whether or not the water running through the pole would cause the carbon fiber to in any way be to produce the electric charge or whatever on that base section. They got the same results whether water was running through it or not, and so that was kind of interesting. But yeah, the reality is guys, just don't get that out of your mind that, well, I'm using DI water, so it's less conductive. No, everything else you're using is conductive. So it really is such a moot point. It's like, wow, you know, and we had that in the IWCA, one of our not bulletins, but one of the trainings or whatever, it talked about how, and that might have been, you know, a little bit of a misleading thing. It doesn't matter. It's a point that we shouldn't even talk about. Carbon fibers is electrifying, or not electrifying, is conductive, and so that's what we need to worry about. That's what's causing the problems. It's not water. It's not water being sprayed on something being electrocuted.
Yeah. I had another question, and you know, this is another science question, I guess. So it's but talking about like arcing and the concept of arcing, which I didn't really know that term until pretty recently, but is that like, you know, is there maybe some ratio for how much the electricity could jump based on how many kilowatts might be running through that, in terms of how much space you need to, you know, how much, you know, how far something could arc from one to the other? You know, I'm just wondering if we know about that, like in what situations would you be worried about that, you know, the electricity jumping and arcing in that way?
Yeah, I'm not gonna be or proclaim an expert on, you know, electricity running through voltage and all, and how many feet and all that you need, because I'm not. But I will say this: if you're following your minimum approach distances based on those categories that we gave in the videos, right, or in the presentation, then they are considering that as a basically straight up pole to a line over here. So if you're following that, you should be in really good shape.
Okay. We had another question from our safety director, Stephen Bright.
This is a setup, I can tell.
Always is. Well done, Mike. Now, I just wanted to jump in on a couple things. You know, it's almost demographics that's driving this, and a lack of training. To be honest with you, I mean, the whole carbon fiber thing was a misdirection, and now it's trying to get redirected back. And the problem is it went on for many years. So there's a lot of those poles out there. Even before that, when I was in the distribution business, I sold many water-fed poles to people that can use them, but don't need any training. Colleges, universities, hospitals. And I don't want to take away from any, you know, sole proprietors and residential window cleaners, but, you know, guys that thought, hey, I can clean something up high because I can now go online and buy something that'll reach it. So that actually is a big contributor to everything we're talking about here, and Mike had touched on it, if these people knew, what they needed to do in the way of training and understanding, electrical resistance and PPE in that regard, none of this wouldn't happen. So for the training world and the IWCA to get, caught up and get all this information in their hands is going to take, some doing. Thank God we have the internet and AI and an OSHA ambassadorship to help push that along. But it's just going to take some doing. We got to reverse a trend. We got to change a mindset, and then we've got to say, look, you can't, it's like the chainsaw world. How do you think those manufacturers feel? Anybody can buy one and anybody can cut off their arm or leg. So it's the same concept. We got to get that information out to all the way down, to the homeowner, because that's where a lot of these people start. And, these guys that clean windows at colleges and universities, that's 0.1% of all the things they do at that location. So there's some work involved, and we're getting there. As you can see, we've got programs, and we've got Mike, and we've got the IWCA. We'll get there. It takes time. And, we are working on another technical bulletin from the IWCA, and it's going to have all this good information in it. We get the manufacturers to include that with their products. Hopefully, might take a meeting or two to negotiate that, but we'll get there. And thanks, Mike. Thanks for your time and energy there.
Yeah,
See,
no
I
problem.
didn't set you up at all.
Tanya,
Tanya.
Good. Thank you so much, Mike, for that great information. And Stefan, you just touched on what I was going to say. It's really about, I think, you have to get the message to the masses. And how do people know what they don't know? And if they're not in the right room, hearing the right information, they're not getting what they need to know to be safe. Because if you ask any one of the people who had an incident, if they knew something different that could have prevented it, would they have done it? And they would have said yes. Right? So it's back to this, how do people know what they don't know? And I'm so glad to hear the IWCA is constantly advocating not only for its members, but for non-members, just people in our industry and in the world that use this equipment, and to do it safely, because it's the lives that matter. And engaging the manufacturers and saying, here, you're going to be getting this equipment to the masses. It's known to produce and be part of accidents that could potentially be life-threatening. Can you insert this information with every single pull that goes out? There's warning labels for everything. And it could be a QR code to, an online video. It could be a brochure. It could be all kinds of stuff. But I think it's so important. 3's too many. 3 is too many. It just blows my mind that this has happened. And you know what? It's because they didn't know. If you look at all of these incidents, you nailed it on the head, Steph, and there wasn't proper training.
Yeah. And I just thank you, Tanya. I forgot to mention this. I know a little bit about the humidity thing from what I understand. Humidity, arcing. From what I understand, the more amps, the easier it is to arc. But again, you don't know that. And Mike had said this, you never know what's in that line. But I do know this, Nathan and everybody, when it is humid out, the higher the humidity, the greater the chances are, because that moisture in the air, to Brandy's point, about water being a conductor, and Mike's comments about water, dirty as it can be, our atmosphere is dirty, and it's going to carry electricity from unexposed wires, or exposed wires, I should say. So just another thing to think about when it's humid. That's another hazard sign that you want to look for in your JHA.
yeah, that's a great point. Awesome. Well, if there aren't any more questions, we'll wrap this up. Thanks everyone for being on here. Thanks, Philip, our executive director, for setting up the Zoom. Thank you, Mike, for that content. This is going to be recorded. You'll be able to find the recording on our website at iwca.org. And also be on the lookout for the bulletin that Stefan and Mike are working on, so we can continue to make window cleaners safer. So thank you, everybody. It's great to see everyone.
Stay safe.
Awesome. Thanks, guys.